Hey guys, welcome back. So this is kind of like the part 2 to the fork frame modification. So basically that fork frame that we did the oversized bushings on, it goes in here and gets pinned up. So those same holes on this we're going to modify. Basically we're going to add 1.5 inches of meat on there, and then we are going to bore those out bigger to the next size up to 2 3/4 instead of 2.5. And then we'll be using induction hardened pins, and then we'll go over that when we get to that point. So right now we have these 1.5 inch pieces that I designed and my friend cut on his 200 amp plasma table. Came out pretty good. So those will get welded on there in alignment, and then basically just set the line boring machine up and cut it. Okay, so I came up with a little kind of a jig type deal. Got a piece of 3-inch aluminum bar going through there, 1-inch spacer on the bottom. Kind of holds these pieces in almost the perfect spot, and then now they'll be nice and uniform to each other. So we'll just kind of get those pushed up there, get them tacked on. We'll fully weld these out, and then we'll line bore it. All right, so we have moved this bucket outside and we have it on end now. We got our pieces tacked in, and we are doing this for the only reason that it's a flat weld position and it will have a more uniform weld all the way around versus having multiple different positions. And it is now dripping who knows what. This came from a dairy. It has a very strong scent, whatever that is. So I'm thinking we're going to weld that top one, and hopefully this is done dripping, and then we can weld that one. Okay, we got this top one. Looks all right. Okay, now we'll see if we can avoid that dripping deliciousness of whatever that is, and get that one welded. So this is my quick idea for keeping that off of that. Seemed like it'll work. All right, we're going to wipe this down, then we're going to weld this one out. Well, our gutter has worked. And welds came out all right. Looks all right, a little inconsistent. Okay, now flip it over and do the same thing. All right, got the bucket back in the shop. You can see we've got some welds on there. So now we are going to get the line boring bar all set up in there and start cutting. Basically same thing as the other video where we just have to cut just a little bit bigger to get the new bigger size bushing to fit in there. And then you might be wondering about this gap on the bottom as well as some of these cracks. This customer is going to be replacing this plate and they're going to be dealing with the cracks, and then I will explain the gap underneath there a little bit later in the video. All right, so I was going to use S-Power to cut this, but the bearings are just slightly too big, as well as the Climax bearings are also too big. But I have done this before, and I happen to have everything that I need to do this job for the Climax. So we will be using the Climax setup for this. So I have it set up like this through these pillow block bushings or bearings, and it actually came out really smooth. Like the alignment is super nice on that. And the critical measurement would be from the center to, I'm kind of going off of this edge on that looks like a machined edge on this frog here. So we got the bar straight. Now we have to, basically we're going to be mounting our drive here. So we'll get that figured out. And then all we got to do is just cut now. Okay, let's get this figured out. And then we can get all this set up. Okay, this is what I came up with. Should work. We're gonna have just enough of travel on this bar. You can see we got to cut about that far, and we have about that much to go here. So we'll have just a little bit extra on travel, and then we'll have to put a tool on this side and then feed it back through that way. The S-Power bar is about 10 inches shorter than this one. So in this exact setup, that would not work. You could, however, cut the floor out, or you could cut a hole there to fit like factory bearings that are larger like this. So we got a cutter set up. Take a light cut to begin with, see how our bearings react and everything, make sure everything looks good. So, all right, let's get to cutting. Okay, so we got our first pass done. It actually came out a little better than I thought with all the interrupted cuts and cutting the hard plasma edge and everything on that. So we have our tool. We're gonna make 2 more passes now. We're gonna make 1 more pass to get the bulk out, and we'll make 1 more pass after that. That'll probably be about like 5 thousandths cut or so. We have our Climax tool bit adjuster here. It works really well. I've had really good luck with the accuracy, and I actually trust this tool. So, like I said, do a little bit of math, and then you can figure out what your stick out needs to be from the bar. That's what we want for our final cut to allow about 3.5 thousandths of crush fit. So we're gonna go underneath that and then come back and take a nice light cut, because there's a distance between the bearings here. We're running a little bit smaller of a bar. There's more likely it's going to have deflection. So that last final cut, you want it to be really light. All right, well, let's get this off and get that cut. All right, we got our final pass done. Not too bad. There is a gap in between the piece I welded on and the bucket there. That's no big deal. We just want a nice tight fit, and we press those bushings in there. So, okay, we will basically move the bar back, and then we'll start the cutter on this side and then feed that way. Ideally, we would be set up closer with the feed, and we would be able to just leave the same measurements and just feed all the way through. But shorter bar and everything, we're not able to do that. So that's the benefit of having like an 8-foot bar versus a 6-foot bar. Is if we had those extra 2 feet, we'd be able to just feed that through. So basically cuts your measuring and adjusting the tool in half. But we can still get the job done, no problem. Here's the second pass on this side. Just trying to get this done. It's almost 9 o'clock at night. Started at 4:30 in the morning. Just trying to finish this last cut and call it a day. we got this side set up and cutting. Just kick my boots up and wait for it to go through the hole. Okay, we are on our final cut. I've been using these inserts that came with the S-Power, and they work really well. Using them right now. A couple other little projects happening. So we got the bushings pressed in on this side. Pin fits perfectly. So what we're gonna do, instead of a hold down bolt, like you may have noticed on the other ones, there was a threaded hole right here, and then there would be like a flange welded to the pin, and then a bolt. Well, that gets messed up really quick, and you know what they use this for, that'll get corroded in there. Even with anti-seize and all that, that bolt will just seize up. So what we're gonna do, for ease of changing pins out in the future, is we're just gonna drill 2 holes here and here and put some grade 8 bolts in it, and good to go. Okay, we got this side all cut. Now we're gonna press these bushings in, and then we will drill the holes in these pins. Okay, so we have induction hardened pin. So we have that really hard outside layer. We're gonna try to drill it with the carbide end mill all the way through. We have a stop set up so that we could repeat this process 4 times without having to do any additional measuring. So let's see what happens. Okay, so we're gonna do an experiment. So I drilled one hole dry. It was a brand new end mill. So now we're gonna use anchor lube and see if that improves the drilling with the end mill. And I know this is probably not the correct way. It's probably not the correct end mill to use. It's probably not the correct setup. And also having an adapter in here for quick change. This wobbles a little bit, as you can see, but it's getting the job done. And these don't need to be precise. Well, I would say it helped, but of course that induction hardening doesn't help the situation. All right, let's get the other piece. So since we're doing 4 of the same thing, we're also gonna try this and see how this compares to anchor lube versus no lubricant. So in my opinion, this one would be basically the same or maybe a little bit less, but it smokes, makes a bigger mess. And from my experience using this in the past, it's likes to stick to everything. The anchor lube will kind of just dry up and then you could like just wipe it off. This stuff is like just like a sticky kind of mess. It kind of goes all over it, all over everything. All right, let's see if we can get one more hole out of that end mill. She's getting kind of beat up. All right, we got our holes drilled, and I just want to say that carbide is one amazing material. That's the end mill, and it finished drilling the hole. Like I said, this doesn't need to be precise, so that's fine. Just a bolt just has to go in there to hold the pin from falling out. So now we're just going to do a little chamfer on the end here. Just a little bit, just to help it slide through and kind of line up when the other frame is in there. So we'll chamfer these edges, and then, yeah, getting close, almost done. All right, well, we got it moved out of the shop. There's the finished product. See that? Tighten those bolts up there. And lock those pins in real nice. The customer is gonna finish the rest of this. They're gonna do the sides and some extra wear plates and things in there. And here's this fork frame. We got the grease lines on there. If you guys are curious how I did that, see that's nice and flat. It doesn't stick up above that. Ran them to a bulkhead fitting with a great zerk. So while it's on the machine, should be able to just kind of lean in, and maybe they'll grease it, maybe they won't, but they're there. Might be wondering about grease fittings for these outside bushings. There's not really any good way to do that. That's why we added these 1.5 inch pin bosses. So it adds a bunch of material, and then we added a high quality hardened steel bushing. So this should last a very long time, and if you just keep your eyes on the pin, you can swap the pin out. But what I'm saying is, if you had a grease fitting anywhere on here, the outside of this, it would obviously just get ripped off. And there's not a lot of clearance inside. So those are not gonna get grease, but these inside ones will, and they got grease seals. So that should be a nice sealed unit. Okay, well, that is it for this video. I hope you guys enjoyed both of these videos. Just a simple line boring job. Thank you for watching. Stay tuned for the next one.